ask, am I audible to all of you? Okay, thank you so much. Uh, my name is Riahin Sadiq, and I'm here from Afghanistan on a scholarship, a student of third semester in BBA in the best university, Islamabad campus, and I will be your host for today's session. I am delighted to see such a wonderful gathering here, and I hope today's seminar will be both informative and engaging for everyone. Before we proceed, let me briefly introduce you about AI Explain You Science. AI Explain You Science is proud to announce its official partnership with Protected Consulting as a seller of EDX LLC and O'Reilly Media, alongside recent strategic alliances with Loom Smart Earth Day, the global clean tech directory, and Chiang Mai Research Education and Publication Private Limited (CREP). In a major step forward, we have further solidified our industry presence through a new partnership with Cisco and the integration of Geeks Hub into our ecosystem, and the collaborative bridge with the Lincoln Global Postdoctoral and Researcher Programme LGPR. Uh, Together, these collaborations ranging from world-class educational platforms and high-impact research publishing to enterprise-level networking and elite postdoctoral initiatives empower AI Explain New Science to deliver unparalleled innovation and value to our global network. This partnership with Cisco, a global leader in networking, cybersecurity, and IT solutions, alongside our synergy with CRIP and LGPR, marks a significant milestone for AI Explain You Science. By integrating Cisco's cutting-edge technologies, CRIP's robust research framework, and LGPR's prestigious researcher support into our ecosystem, we are empowering professionals and academics with the skills and institutional backing needed to excel in today's fast evolving digital and scientific landscape. And now, thank you for your attention. Now, it is my great honor to introduce our distinguished guest speaker, Dr. Shiva Shankar Reddy. Dr. Shiva Shankar Reddy working
Yeah, good
as
evening. Yeah.
yes. Let me briefly talk about his career and aim. Dr. Shiva Shankar Reddy working as SR assistant professor in Sagi Rama Krishnam Raju Engineering College, Bhimavaram, and Andhra Pradesh, India. He is an accomplished academic and researcher with over 16 years of experience in teaching and research in the field of computer science and engineering. He received his BTech degree from GNTU in Department of Computer Science and Engineering. He received his MTech degree, means Computer Science and Technology, from Andhra University. He received his PhD degree in Biju Patnaik University of Technology, Rourkela, India. He received his postdoctoral fellowship from Lincoln University College, Malaysia. His primary areas of expertise include data mining, machine learning, deep learning, medical data analytics, image processing, edge computing, and computer vision. He has authored four books, contributed 25 book chapters, and published more than 130 research papers in SCIE, Scopus, and UGC, indexed journals, and conferences. He has filed five patents, with one granted, and has received multiple Best Paper awards at reputed international conferences. He has organized various faculty development programs, seminars, workshops, and short-term courses at the college level. He has published WOS indexed journals. Dr. Reddy actively contributes to the global research community. His academic achievements are complemented by professional certifications from NPTEL, Cisco, and Coursera, and he has been recognized by Google in 2023 and 2024 for successfully completing the Cloud Career Readiness Program and the Cloud Career Launchpad program. He is member of LMISTE, FAMI, MIAENG, and MCSTA, and is dedicated to advancing knowledge in emerging technologies. We are truly honored to have him with us today. And right now, sir, the virtual floor is yours. Thank you.
Yeah, thank you, Raylan. I was very thankful to you for introducing me. Yeah, shall I start?
You're welcome, sir.
Yeah, I'll sharing my screen.
Yes, it is visible.
Yeah, is my screen is visible now?
Yes, this is it's visible.
Yeah. All right. Very good evening to all. This is Dr. Shiva Shankar Reddy. Already in India, already given introduction behalf of me. So today I'm going to give a session which is designed to guide researchers, especially postgraduate students, PhD scholars, and faculty through the complete research and publication life cycle. From understanding what real research means and to identify research gaps, designing strong methodologies, and finally publishing in quality journals. And this session will provide you a structured and practical roadmap. So this is the overview which I'm going to cover in the today's session. And coming to the research fundamentals, here we are focusing on understanding what constitutes research as opposed to simple implementation on the application work. True research must address a problem, contribute a new knowledge, improve existing methods, or offer new insights. So, as a researcher, it is very crucial to clearly define what is a new in our work. Many papers are rejected not because they are incorrect, but because they lack of a clear research contribution. This module helps participants align their work with academic research expectations. So, what is research? Let us first clearly understand what research actually means, because this is where many students and even researchers get confused. Here, research is about solving a clearly identified technical limitation in existing work. It is not just applying an existing method, but improving, modifying, optimizing, or redesigning it to address a specific problem. In simple words, research must add something new to the knowledge that already existed. So, implementation versus research, if you see the comparison between implementation versus research, if you take an existing model and apply it to a data set and reporting the results, that is implementation. It is not a research. Okay, for example, if you consider uh, a data set, okay, by applying a ResNet 50 model, and if you consider a CFR 10 data set, and if we get the result 92% and more than that, accuracy is not a research, because here the model already existed, the data set is already existed, no limitation is addressed, and no improvement is proposed. Such work will be maybe very useful for learning, but it does not qualify for a research publication. So coming to the research, here what we have to see here, when we identify a limitation and try to solve it, if you see here, if consider an example, if CNN perform poorly on imbalanced data set, and medical image data sets often have class imbalance, and existing architectures may fail to capture important features. Then here what we have to do is, by improving a CNN in performance using balancing handling and introducing optimization techniques, and propose a novel architecture or framework, then it becomes a valid research. So existing model and considering an existing data set, if we apply, it will be considered as an implementation, but not a research. So proposing an attention mechanism combined with SMORT for imbalanced medical image classification is valid research, because here we are using addressing because here addressing a real limitation and introducing a methodological improvement and adding a new knowledge to the field. So coming to the key contributions, when we see the performance improvement, here research can improve in accuracy, speed, computational efficiency. That indicates every small improvements matter if they are well justified. When coming to the robustness enhancement, here a robust system performs well under noise, data variations, real world conditions, making models reliable across conditions in a strong research contribution. Scalable solutions. Here, research addresses challenges related to the large data set and real time deployment and resource constraints, like that. So, methodological advancement. Here, this is one of the strongest contributions, which consists of a new algorithm, new framework, new learning strategy. Such work often leads to high impact publications. Here, it is very important that research requires a technical innovation that addresses a specific limitation, not just application of existing methods. So, before starting any research work, always ask yourself, what is the limitation I am solving, and what is my contribution behind existing methods. Now coming to the research gap, identifying a research gap. Here, after understanding what research is, the next crucial step is identifying a research gap. Many papers fail not because the work is bad, but because the gap is weak, vague, or incorrectly defined. Here, this line explains how to identify a valid, defensible research gap in a systematic way. What is research gap? Here, in a just a minute. Here, what is a research gap? A research gap is a specific, clearly demonstrable limitation in existing research work, and it is identified through a systematic literature review, not assumptions. A valid research gap must be technically precise, evidence based, clearly supported by existing literature. The types of research gaps are performance gaps. Here, existing methods may slow. And coming to the scalability gaps, here some models work well on small data sets. And complexity gaps, high computational cost, long training time, or complex architectures can make models impractical. Reducing complexity without sacrificing performance is a strong research contribution. Whereas coming to the robustness gaps, many models are sensitive to noise, data imbalance, variations in real world data. Here, improving robustness significantly increases practical value. So, coming to the evaluation gaps, some studies suffer from weak experimental validation, limited data sets, and inappropriate metrics. So, here, when we improve evaluation rigor, itself can form a valid research gap. So, coming to the A systematic gap and which we can identify a process is step one. Start by reviewing 20 to 30 recent high quality papers from good journals or conferences in our research area. And we have to focus here on methodology, results, and limitations sections. And step two, we have to create a table comparing methods used, data set, evaluation metrics, reported limitations. Here in this step, it will bring clarity and structure to your literature review. And step three, look for repeated weakness across multiple papers. That means which is having same limitation mentioned again and again, and same failure scenarios and same dataset bias. Here, the repeated problems indicate strong research gaps. Okay. Now, step four, define the research goal. Here, convert the identified gap into a specific measurable research objective. Okay, so here which is incorrect approach and which is correct approach. So here there is a statement, no one has worked on this problem. This statement is vague, unverifiable, and academically weak. That means reviewers immediately reject such gaps. So then what is the correct approach? Here if you see that existing work lack robustness under class imbalance conditions, resulting in reducing minority class recall. If you observe here, there is a specific measurable technically strong, and here the reviewer is going to be acceptable. So a well-defined research gap is the foundation of impactful research, and spending time identifying and clearly articulating the limitation of your work addresses. So at the finally, the strong research does not start with a solution. Here it starts with a clearly identified problem backed by evidence. Now coming to the writing research objectives and novelty. After identifying a clear research gap, the research the next step is to define what exactly we are going to do and why it is new. Here I am explaining how to write a strong research objectives and how to clearly communicate novelty, and which is one of the most common reasons for paper rejection. So here when we see the strong objectives, research objectives must be directly address the identified gap, and here we have to see that specific, measurable, testable, and supported by a clear validation strategy. A weak objective creates confusion, and while a strong objective gives reviewers confidence in the research direction. So this is the objective templates. Here there is a statement to address the limitation of specific gap. This study aims to design a framework that improves specific metric through technical approach. This template ensures that the gap is clear, the contribution is defined, the evaluation metric is mentioned clearly. Another example, experimental validation on dataset demonstrates by improving metrics compared to state-of-the-art methods. Here, reviewers will prefer objectives written in the precise and technical format. Whereas coming to the novelty, novelty is not just about higher accuracy. It's about a technical innovation that enables those improvements. So there is having so many types of novelty. Among them, the first one is combining multiple models or ideas in a new, well-justified way. That is, we'll call as a new hybrid architecture. And second one is adaptive learning mechanism. Here we are designing systems that dynamically adjust a data that is a noise or imbalance. And the third one is optimization framework. Here, introducing a new optimization strategies to improve efficiency or performance. And the fourth one is a theoretical contribution, providing mathematical insights, proofs, or a theoretical analysis. And all of these are valid forms of novelty if technically justified. And coming to the case study, here we are considering a machine learning example. And if you see here existing work, here I am considering a random forest and which achieves 85% accuracy. And there is an issue here. Minority class recall is only 42%. Okay. And which is unacceptable in critical applications, and lack of imbalance handling and optimization is as a gap identified. And designing an optimization integrated framework using smart and genetic algorithms, this will give clearly picture when we identify a gap. To fulfill that gap, we are creating an object which should be a novel, and for that we have to do some contribution by implementing a new novel model. So the novelty statement template is: this study proposes a novel, it may be a technique or framework that addresses the limitations of a specific gap in existing approach. Here, novelty must be a technically demonstrable, not just incremental improvement. Simply improving accuracy by 1% or more than without technically justification is not novelty. So strong objectives tell reviewers what we are doing, what you are doing. Strong novelty tells them why your work matters. Coming to the research rigor and methodology and experimental setup. Coming to the methodology section, one objectives and novelty are defined. After objectives and novelty are defined, the methodology and the experimental setup determine whether the paper will be accepted or rejected. So here reviewers trust results only if they can reproduce them. That is why this section must be detailed, transparent, and systematic. So here the methodology section must include sufficient detail for reproducibility. Another researcher should be able to re-implement your work using only this section. That means it should have an architecture. Here we have to explain how your method works, and it should include a clear visual framework or black block diagram, and any mathematical formulations where applicable, step by step algorithmic flow. A good architecture describes makes description makes the contribution easy to understand and justify. So now coming to the data set, we must and should clearly describe the dataset size, the number of features or classes, and how the pre-processing steps has been done, and data characteristics such as imbalance or noise are there. Here, reviewers, that means here data characteristics such as imbalance or noise, when we see this, reviewers mainly often question results if data set details are unclear or if any incomplete. So if the data set is clear, then methodology can be implemented. So coming to the algorithm details, here we have to explain how the method is implemented. And if you write a pseudocode or step-by-step procedure, and if you write an implementation code, that will be very useful, so that the standard procedures will be followed. Coming to the complexity, finally, after applying a model, here we are finalizing. We have to give the performance of the model. So yeah, we have to give the time complexity. Either we can give the space complexity depending upon our relevant project, the relevant work we have done. Okay. Now coming to the experimental setup. Here, if you see the steps focusing on how the experiments were conducted. So reproducibility is critical for acceptance, especially in SCIE and top Scopus journals. Here, when the data is splitting strategy, here we have to mention clearly how the training data and testing data is splitting, either with 80 to 20%, either with the 70 to 30%, and how the cross validation methods has been used either in k-fold or stratified, etc. Whatever the cross validation, if you apply, we have to write that one. So here improper splitting is a very common reviewer complaint. Now, coming to the environment details, we have to always specify that hardware, CPU, about the hardware, what we are using, CPU, GPU, or RAM, whatever it may be. And coming to the software, and which language we are using, either Python, and which version we are using, and which domain we are using, that operating system also. If you mention here, it will avoid ambiguity, and it will give, it will ensure for comparison also. Now coming to the hyperparameters, parameter values and ranges, and tuning strategy and optimization method, we have to explain clearly, so that how the unexplained hyperparameters reduce credibility will be knowing here. And the baseline methods. Results must be compared against baseline methods and traditional models, and ablation components, and if applicable. Here, without strong baselines, improvements are meaningless. Coming to the statistical validation, single run results are not enough. Okay, so if you use a multiple runs with a different random seeds, it will give a confidence interval, and we can apply a statistical test with like a t-test and ANOVA, etc. So which improves that, which it proves that improvement are consistent and significant. So insufficient experimental detail is one of the most common reasons for proper, for paper rejection, and even good ideas fail if the methodology is poorly described. So strong methodology does not just support your results; it protects your research from reviewer doubts. So results and reviewer expectations. It explains what reviewers expect in a research paper, and why papers often get rejected. Here is a clear, simplified explanation of the slide. Here, what reviewers expect. Here, if you consider, I am considering here a machine learning project. When we submit a papers to the conferences or journals in fields of computer science or machine learning, here the reviewers usually look for these evaluation elements. One is a confusion matrix, which shows how well your model predicts each class, and comprehensive metrics. It will show the performance of the precision, recall, and accuracy of the model. And ROCA and AUC curves, which measures performance across different thresholds. State of the art comparison. Here it will compare your method with recent published methods, and usually shown in a table at the end of the result section. So coming to the ablation study, shows how each component of your model contributes to the performance. So the strong comparative validation is to convenience, to that means we have to convince the reviewer of how our work is strong, including comparing with 3 to 5 baseline models, and testing on multiple data sets, and show statistical significance, and provide quantitative or combination of qualitative results. So it will give more, can be more convinced to the reviewers. So where our these are the common reasons why the papers getting rejected. So when it is unclear research gap, that means if there is problem statement is vague, and no clear limitation in the in existing work, weak novelty, only small changes to existing methods, no significant technical contribution, insufficient evidence. That means limited. That means limited data sets. What we have collected. That means small data sets and missing baselines, and no statistical validation. So coming to the over claiming results, uh, here claims are exaggerated and not supported by evidence. Weak motivation, if you write a weak motivation and a poor literature review, and if you confuse the structure of the paper, by the these are why the paper is going to be rejected, means these are the 5 important steps we have to follow. We have to avoid these 5 steps, then it is easily to select our article. So here reviewers evaluate contribution, clarity, And a well-written paper with moderate results can beat a purely written paper with excellent results. So good research papers need clear problem definition and strong experiments, proper comparisons, and clear writing. Here, the conferences versus general publication. Yeah, if you see the conference papers, here the length should be very shortened. That means the conference paper must should have 6 to 10 pages typically, and we have to focus mainly on core innovation. And coming to the review cycle, here faster review process about 2 to 4 months, and here it will emphasize on novelty and new ideas. And coming to the presentation, authors usually present the work in orally or poster presentation. Coming to the publication, it will published in conference and visibility is usually shorter term. Whereas coming to the journal papers, it will consider 15 to 30 plus pages. Detailed methodology should be there. And the review cycle is minimum, it will take 6 months to more than 12 months. And here multiple revision rounds will be there. And here comparing with conference article, here we have to focus on depth and extensive validation required. And here the experiment should be there. That means we have to show multiple data sets, how the statistical test has been implemented, how the ablation studies has been done. Here each and everything must define clearly, deeply when we are writing a journal article. So coming to the impact, it becomes more permanent academic record and higher chances of citations. So comparing with these two, here early stage novel ideas should be there, and whereas here mature research career development should be there. So the key differences here we have given some timeline. If you see here, the conference will take 3 to 6 months, and journal will take 6 to 18 months. And validation, conference will having a preliminary, and journal will having an extensive. Coming to the reviewer focus, conference will having a novelty, and journal will have a rigor. And revision cycles, conference will have a single, and journal will have a multiple cycles. So journal versus publications. Here, sorry, yeah. Why journal indexing matters? When we publish a research article, a research paper, publication alone is not enough. The quality and impact of the journal matters significantly. Journal indexing determines how visible, credible, and academically valuable our research becomes. So, journal indexing is the primary determinant of research visibility and academic credibility and academic values and institutional recognition. If a paper is published in non-index journal, it may not be recognized by your universities or accreditation bodies. So when we go to the publications, SEI, Q1 indexing journals or Scopus indexing publications, journals for PhD award, and non-indexing journals are often rejected while we are submitting our thesis also, PhD thesis. So coming to the promotions, the faculty promotions heavily weight nowadays, and Q1, Q2 publications are considering and journal with impact factor, recognizing indexing systems. So funding, when most probably granting agencies will check the publication quality before awarding funds. So visibility, indexed journals ensure wide audience research, higher citation probability, and international discoverability. So major indexing systems are having two globally dominant index platforms. One is Web of Science, which is under Clarivate Analytics, and the second one is Scopus, which is a large database, which is under Elsewhere database. Coming to the Web of Science Clarivate Analytics, it is handling science citation index expanded, and Social Science Citation Index, and Emerging Sources Citation Index, that is SCIE, SSCI, and ESCI. Here, coming to the large database, it will coming to the wide coverage, and it will having some quarters, and we will see the next coming slides. So before submitting a paper, here we have to have always we have to verify whether that journal or publication is the indexing status. First of all, we have to check the indexing status before submitting an article. So Web of Science indexing. So Web of Science is considered one of the most prestigious citation database globally, and it is managed by Clarivator. Just now we have already discussed, and now it is highly selective. So coming to the Web of Science, SCI, Science Citation Indexing expanded, which is having high impact factor and has quartile ranking, highly selective, and preferred for PhD and promotions. Whereas it is, we have to see that if your goal is strong academic recognition, aim for SCI only. If you go for SSCI and AHCI, it is SSCI is for social sciences and AHCI is for arts and humanities. These also have impact factors and it is also having some quartiles. Whereas, very important, whereas in ESCI, emerging sources science, emerging sources citation index, for developing, it is only for developing journals. Here there is no impact factor, no quartile ranking, moderate to academic value. That's all. So good for early stage journals, but not equal to SCI. So SCI journals are globally recognized as highest impact research outlets and always prioritize SCI when possible. Scopus indexing overview. Scopus is maintained by Elsewhere, and it is currently the largest abstract and citation database in the world. And the key Scopus metrics are site score and SJR and quartiles Q1 to Q4, where Q1 will be the top 25% journals and Q2 will be the 25 to 50%, Q3 will be the 50 to 75%, and Q4 will be the 60 to 70%. So these are the key advantages of Scopus indexing journals, faster indexing process compared to Web of Science, and wide disciplinary coverage across all the research areas, and comprehensive metrics for general evaluation. So understanding the quartiles. Here I'm going to give explain each quartile. So explains how journals are classified according to specific subject area. Quartiles divide journals into four equal groups, which helps researchers understand the relative quality and influence of a journal in its field. Quartile ranking is commonly used in databases like Scopus and Web of Science. And actually, I'm using quartile. Quartile. What is a quartile? Quartiles represent the ranking position of a journal within its subject category. They are determined using citation metrics such as impact factor, site score, and SJR. The key characteristics of this quartile is citation based ranking and subject specific comparison and updated every year. This means a journal quartile can change annually depending on performance. So quartiles in Scopus versus Web of Science. So this is the quantitative how the data will be differing. Once if you see this, Scopus quartiles are based on SGR ranking, just already we have told, and Web of Science quartiles are based on reports. And yes, we same journal may have different quartiles per subject category, whereas here only SCIE and SSCI journals have different quartiles. So Scopus quartiles in Web of Science, ESA journals doesn't have any impact factor or any quartile ranking. Next, SCI versus ESCI versus Scopus indexing comparison. If you see here, Science Citation Indexing, full name of SCI is Science Citation Indexing Index Expanded, and ESCI is Emerging Courses Citation Indexing, and Scopus is Scopus and there will be no impact factor for ESCI, and there will be a impact factor for Scopus. And coming to the academic value, SCI is considerable very high, and ESCI will comparable with moderate, and Scopus will compare with high. Whereas coming to the PhD or promotions, accepted, SCI articles will be accepted, and Scopus database will be accepted depending upon Q1, Q2. So the top tier researchers we will prefer SCI, and early career researchers has to prefer ESCI. Broad coverage we have to prefer Scopus indexing. So comparing with SCIE, ESCI, and Scopus, SCI is having highest value, and Scopus is having high value, and ESCI is having moderate to moderate value. Status before submission. I already told you. Check the official Web of Science and Master Journal list or Scopus sources page to confirm current indexing and quartile rankings are there or not. We have discussed here. The SCI Q1 and Q2 top Q1 quartiles will having the highest value, and in the Scopus Q1 indexed generals will consider as a very good, and SCI Q3 Q4 articles will be accepted, but it will be considered as a good. And Scopus Q2 Q3 will be acceptable for solid research. It is a moderate. So the low value is already we have discussed the previous slide. The low value is non-indexing, and there will be factor. There will be no quartiles. These all are predatory journals. So when we are publishing an article, try to go for top tier SCI Q1 or Q2. Otherwise, go to the Scopus Q1 or Q2. That's all. So the common indexing mistakes here, so many researchers mistakenly believe that ESCI general is same equal to the SCI indexing. Both are not equal. Why? Because ESCI has no impact factor or quartiles, and here university common committee often don't accept ESA for PhD or promotions. And focusing on quantity over quality. Publishing many papers in low tide journals rather than fewer high quality papers. So committees value quality over quantity. That means one Q1 paper is greater than 5 Q4 low quality journals. And submitting without checking quartile. Publishing in quartile 3 and quartile 4 journals when better options exist can limit career progression. Always verify current quartile on Scopus or JSR before submission. If there is a chance to go for a better option, we have to go for the better option. Why? We have to choose Q3 and Q4. Not verifying indexing. Submitting to journals claiming indexing without verification, those are very risk. Predicted journals often falsely claiming indexing. Always verify on official databases. There are so many clone journals, so many researchers are publishing in this type of journals, and after publishing the article in the journal, but they are not indexing. And the researcher will send a mails to the publisher to index our article, whereas then it will know that the particular journal is having a clone. So before publishing and before submitting an article to the journal, we have to be careful. We have to see to avoid these common indexing mistakes. indexing on official databases before submission, and check current quartile rankings manually, and understand your institution specific requirements, that is the PhD students and postdoc students should be check the requirements of their universities. And we have to prioritize quality venues over publication count. So strategic publishing planning. When to choose conference? Choose a conference paper when early stage idea. That means we have to have a promising concept but limited validation, then we have to choose a conference. So need fast visibility. If you need quick publishing, we have to go for conference. And present your work and get expert feedback before full development, then we can go for conference. Then when we have to choose a journal, so research is fully validated, that means experiments and results are complete. And here we have to see the extensive experiments, multiple data sets and statistical data sets, and career advancement, then we have to consider journals. And career advancement, journal for promotion, tenure, or PhD requirements. So conferences, choose a conference when early stage idea. Publish in a conference, then extend your journal paper. When we are extending, we have to use important, we have to follow the important rules. We have to follow the important rules. Maximum 30% new content, that means new experiments, new datasets, and additional theoretical analysis should be there. So when we are using new datasets or experiments, test on different datasets and add ablation studies, and we have to include complexity analysis also. And we have to see that we have to mention clearly that the journal paper is an extended version, and rewrite section in like introduction and methodology, and add new insights instead of copying testing. That means after extending the article from conference to journal, we have to follow these four important rules. Okay. So common mistakes to avoid here, we have to see that submitted weak work to top conferences, and sending immature research to journals, and insufficient comparison with other methods, and ignoring statistical validation is not good. So the best strategy for PhD scholars is that progressive publication cycle. That means every 1 to 2 years, mostly the researchers has to focus on Scopus, Q2, Q3, or ESCI, and having a good conferences. And coming to the mid phase, that means here 2 to 3 years, here the we have to build research credibility, and we have to focus on Scopus Q1 or SCI Q3 and top conferences. When coming to the final phase here, that means more than 3 to 4 years, we have to target highest impact implications. That means publications. That means we have to concentrate on SCIE indexing Q1 or Q2, and we have to go for a premium journals. So quality over quantity. Quality publications matter most. That means a what I mean to say, one strong paper will greater than many weak papers. Okay, that is the quality over quantity. One strong paper greater than many weak papers. That is the only single sentence we have to remember. That's all. So coming to the benefit strategies, best strategies maximize speed and impact, and build progressive portfolio, and meet career requirements, and maintain ethical standards. So plan your publication roadmap early, balance conference and journal outputs. Always prioritize research quality over quantity. It is very, very important. Professional response strategy. When we get any feedback for any reviewer comments, we have to be careful. We have to follow the 4 step response process. Read all comments. So before replying, carefully read every reviewer comment and identify whether the reviewer is questioning novelty, methodology, experiment, clarity. Depending upon that, we have to respond by saying that thank you for your valuable suggestion, like that. Okay, and we have to, whatever the reviewer suggests the points, we have to address each and every point, and we have to able to see that each and every point should have an evidence, and we have to show which line we have implemented, which line we have modified in the landscape. That will give more confidence to the reviewer. For example, if you see the response template, suppose a reviewer will comment like this: the novelty of this work is unclear. How does this differ from existing methods? Then, as a response, as a review, as a researcher, we have to respond like this: thank you for raising this important point. We have now added a detailed comparison table, and we have to mention, we have to give an evidence on which table, on which page it was highlighted. Okay, and action taken. We revised section 3.2 to clarify our contribution is aligned with existing metric. Like that, we have to show each and every point. So whenever reviewer suggests any comments, the responser, the researcher should be very careful to answer politely. Now, this is a case study which is having a success story. If you see, a reviewer concern, novelty is unclear compared to existing approaches. Then other action should be like this: added comparative table and clarified contribution sections highlighted in technical innovations. So outcome, paper accepted after minor revision. If you give politely the suggestion comment, and if you address each and every point with an evidence, then we will get minor revisions, or we some, there is some cases there is a chance to get acceptance also. So your response tone and thoroughness often determine acceptance more than the original submission. So pre-submission checklist. So when we are submitting an article, we have to follow all these things: and problem definition, contribution quality, literature review, experimental rigor, the documentation, final verification. Here the very important. After entire document is ready, we have to proofread thoroughly. We have to check formatting guidelines. We have to check, verify all figures and tables are there or not, all cited or not, and we have to check the other details whether they are right or wrong. And we have to go for ethical standards, and we have to check for the no plagiarism and no A. Nowadays, no A should be there. Proper citation should be included, no duplicate submissions, and other contributions should not be cited here. So finally, we have to remember that quality over quantity. So already I told that one quality paper will be the will greater than the more weak papers. That's all. So these are the key takeaways. And research is problem solving. Research focus on solving specific technical problems and not just implementing existing methods. And it emphasizes identifying clear limitations in current approaches and support with evidence. Every claim in research should be backed by rigorous experiments and statistical validation. And evidence is everything. Clarity plus rigor is equal to success. Well written papers with clear contributions beat poorly written papers with good results. And here communication matters. Plan your roadmap, plan your publication roadmap early, balance conference and journal outputs. Always prioritize quality over quantity. Yeah, thank you. Any queries?
Thank you very much, Dr. Shiva Shankar Reddy, for such an insightful and
Yeah,
informative presentation. We truly appreciate you taking the time to share your valuable knowledge with us. In this part, if anyone from the audience has
yeah,
question,
yeah.
please
Thank
feel
you.
free to raise your hand or write your question in the chat box.
Yeah, thank you. Thank you so much. Okay.
Okay, thank you for all. If
Thank you so much
there,
for your patience for
okay,
listening my session.
Yeah,
thank you,
Yeah.
thank you.
and I don't have a question, but I just want to thank Dr. Shiva Shankar Reddy. He spared his precious time for us, and I'm truly thankful for him. Thank you so much for coming and being with us. Really, really, thank you so much for coming. It was a really great session, and I hope that listeners over here have learned a lot of the things. And I hope that plenty students over here have learned a lot of the things. Thank you so much, Professor.
Thank you, sir. Thank you.
Once again, thanks. If there are no further questions because of shortage of the time, and we will move towards concluding today's seminar. Once again, I would like to express our sincere gratitude to Dr. Shiva Shankar Reddy for sharing such valuable insights with us today. I would also like to thank all the participants for joining and making this seminar a success. We hope this session was informative and beneficial for everyone. With this, we come to the end of today's seminar. Thank you all for your time and participation. Have a nice time ahead. Thanks, everyone.
Thank you. Thank you so much. So we are leaving.